G'day Year 9, it's me here, and this is a video for your rate, ratio and algebra revision. I'm going to go through work solutions on every question on your revision sheets here for you to enjoy in the privacy of your own home or the great Classroom S209. So here we go, Year 9, Unit 1. Rate, ratio and algebra revision. 1. Write kilometres per hour in words. Well, that might have been a bit of a giveaway. Kilometres per hour. So obviously km means kilometres, the forward slash means per, and we use H for hours, right? So there we go, the question 1, done. Right, question 2. What will 5 kilograms of apple cost when the price is $2 per kilogram? Set out your working. So yes, working matters. In fact, if you haven't noticed already, take a good look on the side here. If you can, does that work for you? Look, it tells you what you're being marked on. If you want to get really, really good marks, there's a lot of good hints there. So question 2, I expect to see something like 5 multiplied by 2, 5 kilograms at $2 each. You could have also written it the other way around as 2 times 5, doesn't matter to me, equals $10. All right, there we go. Make sure you got your units on for dollars. That's question 2. Question 3, simplify the following. And it shows 4a multiplied by 5. Now that's the same as 4 times a times 5. Remember that you don't need to have the symbol shown in there. Doesn't matter what way around you multiply things, we've got 20a. Now by the way, you could have just written that. I just wrote that to just by way of explanation of this is how it works. B is 3a plus 2a. Let's think it out philosophically. You've got 3 blobs of a, you don't know how much it is, and you're adding it to 2 blobs of a. What are you going to get? 5a. Remember that very important principle behind all of this of like terms. You can only add or subtract like terms. Alright? That's question 3 done. Question 4. Might change colour. Got a black pen as well. Isn't that exciting? Question 4. So if r equals 5, what is the value of 3r squared? Right, first step is we do substitution. Substitution, big word, it just means putting the value into the expression. So that'll be 3 multiplied by 5 squared because r is 5. Then you have to remember your order convention. Order convention, indices, then brackets, then your multiplication, division, then your addition, subtraction. Do your indices. You got a squared there. That is absolutely what you must do first. You must do the squared first. 5 squared is 5 times 5, which is 25. So we get 3 times 25, which is 75. All right. Now, it says to circle the answer, so you should have circled B, and then you should have shown that working to justify your calculation. That's question 4. Question 5. All right. There is one of the following ratios that is not the same as the rest. Circle the odd one out. Now, there are many ways you can do this question. The way I've decided to do it right now on the fly is I'm going to simplify each of these. So find the simplest version of it. The same as simplifying fractions. Alright, so, what's the biggest number that goes into both sides? With this one, I can see 2 goes into both sides. With this one, I can see 3 goes into both sides. With this one, I can see 4 goes into both sides. With this one, I can see 6 goes into both sides. All right, so that gives us 1 to 6, 1 to 6, 1 to 4, and 1 to 6. The odd one out stands out pretty clearly now, doesn't it? That's the odd one out. And, well, I've already shown you mathematical reasoning. Essentially, it says simplify all of them. And one of them ends up being 1 to 4. 3 marks for the justification there. You better have some good points. Show that justified. Say you simplified them all. Say that one of them simplifies the difference to the rest. There you go. But 3 marks, a lot of marks in there. Watch those mark schemes. All right, that's question 5. I'm now going to pause and magically clean the screen. All right, welcome back. We're up to question 6 now. So question 6 reads, find the cost for 1 apple if 15 apples cost $4.56. Show how you calculated your answer. So again, some of you are just going to go, oh, well, that's $4.56 divided by 15. I don't mind. So 15 apples is $4.56. I'm going to take the chicken way out here and do it a very simple but pretty way. If I wanted just 1 apple, all I go to do is divide by 15 on both sides there. 15 to 1, $4.56 divided by 1. Uh-oh. Hey, you got a calculator spare anyway? You just grab one out of the bottom drawer. Just a moment. All right, so if you put that in the calculator, you'll get 0.304, which rounded is 30 cents. All right, so that's question 6. Question 7. Getting into the algebra. So 3x plus 3 is 4. 2 steps, the opposite of, remember that when you're doing solving, you go in reverse. So you do your addition, subtraction first. Opposite of adding 3 is subtracting 3. Did I write the question down right? No, I didn't. It was 24. That's more like it. All right. So take 3 from both sides. You get 3x is 21. Opposite of multiplying by 3 is dividing by 3. We get x is 7. And that's the answer. Notice correct setting out. Every step, work down the page. Right? There were 2 marks there. One of them's for actually getting it right. The other's for your setting out. You're working out in the middle here. Particularly that step there would be critical in getting full marks for an algebra question like that. Just having that line there written. Pretty important. Okay, 7b. So that was A. This is B. Now, I've seen before students get freaked out by this terminology, LHS, RHS. Look, all it means is left-hand side and right-hand side. So when we had our equation, we had 3x plus 3 is 24. That's your left-hand side. It's left of the equal sign. That's your right-hand side. It's on the right hand of the equal sign. Don't overcomplicate it. So what they're expecting you to write is LHS is 3x plus 3. They wanted you to put the value in. So that's what they mean by substitution. Put the value in. 3 times 7 is 21. We always do the multiplication first. And you'll end up with the left-hand side equals 24. The right-hand side, on the other hand, it's already 24. So therefore, your left-hand side equals your right-hand side. the solution of x is 7 is correct. See, if you've got the correct answer, if you put the value back in, your left-hand side will always equal your right-hand side. That's all. Okay, so let's keep going. Question 8, I'll get on the board here before we do a magic cleanup again. Bob ran a number of laps around the school oval. Sue ran 4 more laps than Bob. Together they ran a total of 28 laps. Which equation could represent this? So, what do we got? X is Bob's number of laps, so Bob is X. Sue is 4 more laps than Bob, so that's X plus 4, add 4 onto Bob's laps, and the total is 24. So that means that that plus that should equal that, right? Bob plus Sue should equal the total. So if I write that out, I get X plus 4 is 24, but we can combine something there. What's one lot of X plus one lot of X? 2 lots of X. So we get 2x plus 4 is 24. What one's that? C. So the answer is C. 2x plus 4 equals 24. All right, I'll be back. Okay, we're on to question 9. Find the hourly rate of pay for a person with a weekly wage of $486 if they work 4 days for 8 hours each day. Show how you calculated the answer. Okay, again, there are a number of ways I would accept this answer being done. As long as it makes sense and you show you're working, you're going to get the marks. Okay, so one way you could do it is the total hours, 4 days, 8 hours per day. So our friend here has worked 32 hours. All right, and then if you wanted to find the hourly rate, we got paid a total of $486 for 32 hours. So it's $486 for 32 hours. We divide by 32, we'll get the rate for 1 hour. So 486 divided by 32, and if you round it properly, you'll get $15.19. Do make sure to round it properly. The actual number I had in my calculator there was 15.1875. Third decimal points, 5 or more. 5 or more, add 1 more. 4 or less, let it rest. Makes that a 9, so it's $15.19 when you round it. Now, verify your answer. That was A, that's B. All right, so quite a few ways of doing that. But look, essentially the hourly rate times the number of hours should give us the total, right? So if I put in here 32 times 15.19, sorry, the other way around, the hourly rate doesn't clean up well, this whiteboard. The hourly rate, 15.19 times the hours of 32, 15.19 times 32, and you know what? It's going to be close, but not exact, because we rounded it. Remember, we rounded the answer back here? So, look, it's okay. Verified. It's all right, but, you know, just note for our record that, yeah, you've got a little bit of rounding error that we introduced back here when we rounded the answer, okay? So that's okay. It's close enough for what we're doing here. Mind you, we are moving towards exact values as per some of the things we've been looking at in class, in the extension class. So we don't get these little errors that come on the edge here. Anyway, that was question 9. Question 10. A child loses 56 Lego blocks and now has 574 blocks left. What percentage of the original number of blocks were lost? All right, we don't know the original number of blocks. So a good place to start, I'd say, is what is the original number of blocks? How do we work that out? Well, you lost 56 and you've got 574 left. All you got to do is add them together. It'll give you the original number of blocks. So 56 plus 574 is 632. So originally there were 632 blocks. Right, now it asks for what percentage of the original number were lost. Okay, so let's think about this logically. We lost 56 out of 632. That sounds like a fraction to me. Sounds like division, sounds like a fraction. I'm happy with either of those interpretations. Either way, you're going to get 56 out of 632. And what do we do to turn anything into a percentage? Multiply by 100. And that's going to give us our answer here. So 56 over 632 multiplied by 100. And I get that. I've got 8.86 rounded to 2 decimal places percent. So therefore, if you were going to explain it, you'd say 8.86% of the blocks were lost. Yay! Back in a moment. Okay, we're up to question 11, I believe. So we're into the B level stuff. So 3x plus 7 here equals 27. So this is question 11. All right. Now, the first thing you need to do when you've got brackets, actually there are two ways of doing this. I might show you both ways of doing it, just for your own intellectual enjoyment. Right, I'll put one way here, one way here. Right, the general way I've shown you in class is to expand first. So that would be to, what's on the outside there has to be multiplied by everything on the inside. So you get 3 times x, which is 3x. Plus 3 times 7, you've got to be multiplied by everything in there. That's the most common mistake I see. Is 21 equals 27. You then solve the same way as we have done in the past. Do your addition, subtraction first. Opposite of adding 21 is subtracting 21. So we get 3x is 6. The opposite of multiplying by 3 is dividing by 3. And we get x is 2. Remember, you could always check that answer by putting 2 back in there and checking it works. But just for your amusement, as you are an extension class, there's a second way of solving this that's mathematically valid. If everything here is multiplied by 3, you could do the opposite of multiplying everything by 3, which is dividing everything by 3. In this case, that would get rid of your 3 and leave you with x plus 7 is 9. Then the opposite of adding 7 is subtracting 7. Therefore, x is 2. Both of those ways will get you full marks in an exam, but just be careful because often people make terrible mistakes going this way. You've got to be mathematically valid. Right, so that's 2 ways of dealing with that one. And B then, so that was A. B has written 5x over 4 is 8. Again, remember opposite operations. Always, algebra solving is about opposite operations. Opposite of dividing by 4 is multiplying by 4. So you get 5x is 32. Right, opposite of multiplying by 5 is dividing by 5. So I'm going to do that. And I'm going to get x is, well, 32 on 5. Or if you do that out, it'll be 6.4. Now, so 5, and you know, you could always check that. 5 times 6.4 divided by 4. I made a mistake, haven't I? No, I haven't. Yeah, 5 times 6.4 divided by 4. Yeah, no, that's right. It's all good. I was just mucking around there. I put 6.4 back in this formula to check I got 8. And I wrote it in my calculator wrong. Anyway, so moving along. So question 12. Here we go. The graph below represents sales totals for Mrs. Jones' farm stall sales. Jams. Oh, she sells jams, pickles, flowers, etc. Look at that. Beautiful, irrelevant information to the question. All right, then it goes A. What is the typical value of a sale from her farm stall in dollars per sale? So what you've got to do here is, well, it only ever tells you how many sales there are. Look at the graph. It tells you the number of sales and the total amount of dollars for it, all right? So from there, we need to work out dollars per sale. What I suggest is picking off a convenient data value. So here, I'm looking perhaps at this point here because I can see it's clearly on the line. I don't know if that's showing for you, but I'm going to pick off that data value because I can see clearly where it sits on the axes. So let's do that. All right. So if 40 sales, that data point I was pointing to, 40 sales gives you $140 worth, and you want the price per sale, you want the price for one sale, same technique we used earlier. Divide by 40 will give you the value for one sale. So therefore, one sale is, I should just do that in my head, don't I? But I'm not completely well right now, in case you haven't noticed. So one sale is $3.50. All right, so going from there, B. So that's A. A is, yeah. You could have written in words, particularly the A-B level, good idea. Typical sale is $3.50 per sale. Right, B, Mrs. Jones donates 70% of her stall sales to her favourite charity. How much will she be able to donate if she makes 200 sales this week? All right, well, 200 sales, using our previous data, if one sale is $3.50, 200 will be 200 times $3.50, which is $700. Right, and we then want to know what 70% of $700 is. Now, percentage is a number over 100. So 70% means 70 over 100. Of means multiply, 700. Now, if you were doing that without a calculator, there's ways of making that easier. Zeros can cancel. 7/10 of 700. In my mind, 1/10 will be 70. 1/10 will be 70. 7/10 then will be 7 times 70. $490. If you don't have a calculator, it's still doable. 1/10, 70, 7/10 will be 490. All right, did I make any errors there, or are we good for now? 200, I definitely did that right, didn't I? Yeah, that's all good. Okay, I'll be back. All right, question 13. A rectangular field has side lengths measuring x and x plus 2. Draw a diagram of the field with its measurements. So all we're expecting there is, well, a rectangle. It asks to draw a rectangle, draw a rectangle. So you've got x and you've got x plus 2. That is A. B, write a simplified expression for the perimeter of the field. Now, remember that perimeter is the distance around an object, right? So in this case, think of each side here. That's x plus 2, that's x plus 2, that's x. Look, if I wanted to be technical with drawing this, I could have put right angles on everything. That's a bit excessive, though. At this stage, anyway. Anyway, perimeter, you've got to add all the sides together. So let's do that. So it's going to be x plus 2 plus x plus 2. So what do we got there? How many x's? 1, 2, 3, 4 lots of x plus We've got 2 lots of 2, giving us 4. The answer is simply 4x plus 4. All right, A-level, jumping straight into the A-level. Isn't that great? All right, let's do this. Question 14. 12 people meet for dinner and spend a total of $492 on the restaurant bill. Meg spent 6% of her weekly wage on her share of the restaurant bill. How much is she paid per week? All right. So 12 people paid $492. To find what Meg paid, which is one person, how would we do that? Divide by 12. Similar technique to what we've seen elsewhere. So 492 divided by 12 gives me $41. Right, now I'm going to use a more advanced version of that exact technique to solve the second part of this, because it didn't ask us how much Meg paid. It said Meg spent 6% of her weekly wage. In fact, I'm going to show you 2 ways of doing the second part. One of them is sort of your more expected way, and one of them is a much more powerful algebraic way that, you know, it's really cool if you get comfortable with it. All right. So what we've determined at this point, let's write this here, is we know that 6% of Meg's wage, Meg's weekly pay, rather, 6% of Meg's weekly pay is $41, okay? So method 1 is similar to this. If 6% of the pay is $41, I can do a 2-step trick here. I can find out what 1% of her pay is, to then find out what 100% of her pay is, because 100% of her pay is her pay. So that's one way you can do it. So to do that, I divide by 6 to get 1%, and then multiply by 100 to get 100%. And as long as you do the same here, you will find how much Meg is paid. So let's do that. If I do 41 divided by 6, you'll get $6.83 kind of recurring there. The 3's go on forever. So if you then multiply that by 100, you're going to get 683.33, because those 3's go on forever. So therefore, pay of 683.33 per week. I want to show you a second method now. So that's a similar method to this. This is called the unitary method, because we found out the value of 1 unit, and then we use that to solve the problem. I'm going to show you method 2 though. And that pretty well uses this definition. Let's I don't know, W be, we're going to use the letter W for Meg's weekly pay. And what that says is 6% of W is 41. But what's that as a decimal? What's 6% as a decimal? 0.06. Of means multiply. You can write that expression. 0.06W equals 41. How do you get W? It's just a base algebra equation now. If you can write that, you know, you're laughing. All right, so what we've got to do now, I really like using red. Where'd the red one go? Okay. Opposite of multiplying by 0.06 is dividing by 0.06. All right, remember opposite operations. So 41 divided by 0.06, straight away gives you the answer. Meg's weekly pay is $683.33. So if you can write that equation it's easier than doing it that way. It's quicker, it's easier, and it's more reliable, but you've got to see you can write that equation before you can enjoy the benefits. All right, and verify, verify your answer. So verify, go in reverse. A nice way of verifying is to go in reverse. So if that was Meg's pay, 6% of her pay if you worked out 6% of her pay, you're going to get, well, rounded to $41. Then for the dinner, $41 times how many people? 12 people. You're going to get that total of $492 again, hopefully. 12 times 41, your calculator. Yep, got $492. Right, you've then verified. So essentially the best way of verifying, the best opportunity in a lot of these cases is to do it in reverse. The other opportunity is to do it a completely different way. And, you know, there's opportunities there that I would accept too. But in this case, I think that's probably the cleanest way of verifying your answer. I'll be back. And we're back. We're now looking at question 15. In an election between two candidates, a person who got 58% of total votes won the election by a majority of 960. Find the total number of votes. All right, that's a bit tricky because it says a majority of 960. It doesn't say how many votes you got to start with, or yes. Now, what you need to realize from the start is if one candidate, well, yeah, they're saying two candidates. If one candidate got 58%, what did the other one get? The other had to get 100, take away that, right? The other had to get 42%. So that means the difference in their percentage vote is 16%, right? That's the difference between the two candidates, 16%. And they're pretty well saying by a majority of 960, they're saying that this candidate got 960 more votes than this candidate. So from that, therefore, 16% of the vote is 960. Okay, 16% of the vote is 960 votes. You need to be able to get that out before you can solve this. So the first method, where we go 16% of the vote is 960, we're going to use exactly the same technique I used on the previous question. You can use that to find 1% of the vote, which will then give you all of the vote. Right, so do a divide by 16, a multiply by 100. So that divided by 16 actually goes quite cleanly. It gives you 60. And then 60 times 100, 6,000. So it's saying there were precisely 6,000 votes. The second method, again, starting with that logic that 16% of your vote is 960, we could say, well, let V be the vote. 16% as a decimal is 0.16. So 0.16V is 960. If you can write that, again, you're laughing. The opposite of multiplying by 0.16 is dividing by 0.16. And unless I've done something terribly wrong, that better give us 6,000. So I do 960 divided by 0.16. It sure gives me 6,000. So no matter which way you do it, 6,000 votes in total. Hopefully that answers the question. Yes, it does. That was the total number of votes. Question 16 is, so moving on to 16, is a what looks like a truly enjoyable algebra question. So let's do it. 2 4x take 3 equals 3. 3x take 2. I'm going to take the normal advice I give you, which is remove those brackets first. I'm going to do the partial claw. We're going to do more claws later in the year. Make sure we expand everything we should. Remember what's on the outside gets multiplied by everything on the inside. So that gives us 2 times 4x, that's 8x. Then 2 times negative 3 gives us take 6. 3 times 3x gives us 9x. And 3 times negative 2 gets subtract x again. All right. Now, we've got x's on both sides. The technique when you've got x's on both sides is to add or subtract them from both sides to, well, get rid of them from one side. So your options here are, you've got 8x on one side and 9x on the other. Remember, the negative belongs to what's after it. That does not affect anything right now. So you can either subtract x from 8x, you can either subtract 8x from both sides, which would get rid of it from here, or you could subtract 9x from both sides, which would get rid of it from this side. Now, I tend to avoid negatives where possible to avoid the additional confusion that sometimes happens for people. So what I personally would do here is I would subtract 8x from both sides, because that'll get rid of it here, but leave that as one positive x, okay? So doing that, remember, negatives belong to what's after it. I will get negative 6 equals x take 6. From there, I want x by itself. The opposite of subtracting 6 is adding 6. Adding 6. I said adding 6, and then I wrote a subtract. Isn't that great? Anyway, negative 6 plus 6, you'll get 0. By default, we always put the variable at the start there, so I just switch that around. It tells me x is 0. Interesting answer, and perhaps an unusual answer that you might not have seen before. However, the way to check that, of course, is to put it back in here. If I put that back in here as 0, I'd be left with 2 times negative 3. That would evaluate to be negative 6. On this side, if that's 0, I'd end up with 3 times negative 2, which would also give me negative 6. Right, if you put the values back in here, if you substitute it back in, you'll end up with negative 6 equals negative 6. That's sweet. It's all good. The answer is definitely x is 0. All right, that's question 16. All right, welcome back. Now we have question 17, which is an interesting one. All right, so an area rule for a rectangle is length times width. I might actually write that down. That's going to be useful later. I don't use the word geek. I prefer to identify as nerd. Draws a series of rectangles where each rectangle is always 2 centimeters longer than it is wider. Sketch and label the sides of an example rectangle. So yeah, all it wants there is a rectangle where it says it's always 2 centimeters longer than it's wider. So if the width is 4, the length has to be 6, right? The length has to be 2 more than the width. We would accept anything for that sort of question, as long as you've labelled it. So the first part here, it's actually is very easy to get. B, now what we're going to do is, and there's a couple of ways of doing this, but I'm going to say let the width be W. All right? So if we want a general rule for the area, remember area is length times width, but what we've got here is the length is always 2 more than the width. So the length could be written as the width plus 2. All right? The length is simply the width plus 2. So if you put that in a formula, the length is the width plus 2 times the width. So you get this formula of W plus 2. That's the cleanest way of writing it, because it's all of that multiplied by W, and that means the same thing. All right? There is actually a second way you can end up doing it. You could have done it where, well, the width will be 2 less than the length. And if you do it that way, I think you'll end up with a formula that looks like this. So, you know, if you did it a completely separate way and ended up with a formula like that, that's all right as well. It's still length times width. All right. Now, what would the area be of a rectangle with a width of 7.5? So the idea is, if you made a nice rule in the previous part, this is going to be a lot easier for you because it's telling you the width is 7.5, so W is 7.5. You simply can put 7.5 into this formula. So it's going to be 7.5 times 9.5. We'll put that in a calculator. See you, Poppy. 7.5 times 9.5. And we've got 71.25. What units are here? It was all in centimetres. Remember, area is squared, so you should get centimetres squared. All right. Now, for the fourth part, it says, what dimensions could a rectangle have if its area was 168 centimetres squared? So remember our rule here? That gives us 168 equals the width plus 2. Now I'm going to be honest with you here. The techniques that you need to solve this properly involve year 10 quadratics, and I am not going to force you to be able to do that at this stage. So essentially trial and error. I think looking at those numbers that it'll end up being 12. Yeah, trial and error for different values of W. You will find, so trying different values for W. It's just trying different values. That's what I mean by trial and error. You will find that W is 12, meaning width of 12 centimetres, and as the length is always 2 more, the length will be 14 centimetres. Okay? So that's that question for you. Did you enjoy that? Next one's the hardest one. All right, I'm going to do the mislabeled second question 17 here. Now, for the record, this is the hardest question on this sheet, and I've been asked by teachers about this one before. So if I stuff it here, I don't redo the takes. It's just going to be as is, and I'm doing this off the cuff. So here we go. There will be multiple ways of doing this, but here we go. The difference between the marked price and the sale price on the item is the same as the difference between the cost price and the sale price. Find the percentage profit based on the cost price if the discount is 16 2/3 of a discount of 16 2/3% is offered on the item. Now, the first thing you need to get clear in your head here is the order of these items. Cost price is how much the shop paid for it, right? They then normally put it at a marked price. So they'll, add 50% or whatever it is to what it cost them to get the product, and they'll mark it at that. But then they've had a sale and they've marked it at less than that. So there's a sale price. So logically, the order of these three things they're talking about is there's a cost price, the amount the shop paid for it. Next up is the price they sell it for when it's on sale. And next up again is the price that they put normally on it. So you need to have that order clear in your head. Now, I'm going to start by saying, let P be the marked price. We're going to start at the marked price. So this is P. Now the question tells us that a discount of 16 2/3% is offered on the item. That means that it's a discount, it's on this item. It's 16 2/3% off this. Right? Now what that means is, well, what's 100% take away 16 2/3%? I believe that's 18 and 183 and 1/3%. Okay? So the sale price is actually 83 and 1/3% of P. That makes sense, guys? If that's 100% of your price and you discount it by 16 and 2/3%, the sale price will be 83 and 1/3% of P. The next important thing to tie into this is it says that it's the same difference between these two as these two. So again, if I do 83 and 1/3, and I take away 16 and 2/3, I'm going to get 66 and 2/3%, I do believe. That work for you? 76, 82. Yeah, mate. All right, so this will give us 66 and 2/3% of P, because again, it's a fixed amount between each of them. Now, that's all nice and well and fun, but it wants the percentage profit. So percentage profit is calculated on how much more you're getting between these two levels, right? Because it costs them this much and they're selling it for this much. So we need to know the percentage profit. What percentage of profit does it constitute in selling it for this relative to this? So I'm going to write that theoretically. Percentage profit is your profit divided by your cost price. It's hinted that the percentage profit is based on your cost price, which is one thing that gives that away. The second is logic. Well, if I got this calculator for $40 and I sell it to you for $50, well, the profit's relative to what I paid, isn't it? So it'll be like the $10 profit divided by the 40 I paid for it by 100% to make it a percentage, and you'll say I made a $25 profit. And that's all right if I'm dealing with, ripping off students for really nice calculators. But this question's a little bit weirder than that. I'm just going to note we have to multiply by 100 to turn that into into a percentage. So I'm going to use my expressions here to do this now. And what I've got is the profit. The difference between those two was 16 and 2/3%. Now, as a decimal, well, no, I'm going to keep it that as a moment. I'll keep it as 16 and 2/3% of P. That's my profit, while the cost price was 66 and 2/3% of P. Now, from here, there's a few different ways I could do it. I am going to... They're actually common fractions. Would you forgive me if I made them fractions? Essentially, that fraction there is 1/6. And that there is 2/3. Yep. Now, remember P of means multiplication. So I'm essentially saying, I'll do it back here. Remember of means multiplication? Now what that means, in a fraction, what's anything divided by itself? What's 8 divided by 8? What's x divided by x? What's p divided by p? They cancel out. You've got 1/6 over 2/3. Right? I can now essentially do a fraction trick that I may or may not have shown you before. If you have here, this is a useful fraction trick. If you have a fraction on top, the denominator can go on the bottom. Also, if you have a fraction on the bottom, the denominator can go on the top. All right, useful tricks you can use with fractions. Essentially, that means the 6 can go down and the 3 can go up. I'll leave you to think about that. But what that gives me is I end up with 3 over 12, which is 1/4, and I get 25% discount. Now, if you wanted to, that was an A plus plus, absolute A plus 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 way of explaining this. The other thing you could have done at that point is turn that all into decimals, but you just have to be careful with rounding error. So another way of doing it, I'll just show you on the side here. If I turn that back here into decimals, I would have got 0.16 recurring over 0.66 recurring times 100. The p's still cancel out, so you would have got 0.16 recurring over 0.66 recurring times 100. You could then put that in your calculator. You'd have to put in the recurring a bit or it's going to stuff it. 66666 and 0.6666666 there times 100. And look, when you round it, you'll still get 25%. All right? So for you A plus students, that was a hard question. All right? So one way of looking at it, essentially, if you can get it to this point, you're laughing that the profit was 16 2/3% of the original mark price, and the cost price was 66 2/3% of whatever the original mark price is. If you can get that logic out, I'm really impressed. You've done really well if you even got to that. You got to that logic, okay? Hard question. Good on you for following me if you have. All right, we're on the last question. So it's been a big revision book, and my kudos to you if you're still here. So question 18. 2 trains leave stations 60 kilometres apart. So I've decided that I'm marking it, drawing a line 60 kilometres, and they're heading towards each other on parallel tracks. Train A is moving at 30 kilometres per hour, while train B is moving at 50 kilometres per hour. When do they pass each other? All right, so we want a time here. We want the time that they meet. All right, so, you know, as with most complex problem-solving questions, I highly recommend defining your variables. I'm going to let the letter T represent the time the trains meet. Right? From that logic, I can say that train A, where it's at any moment in time, A will be at 30t. So for example, after 1 hour, it will have travelled 30 kilometres. After 2 hours, it will have travelled 60 kilometres and so on. So you can see where that comes from, right? A will always be located 30t away from where it started, right? B, in turn, will be at 50t, whatever. So at 1 hour, it'll be 50 kilometres travelled. At 2 hours, it'll be 100 kilometres travelled and so on. So the beauty is, if you can tie this together into a formula, the idea is that we want to know at what time these two together have travelled 60 kilometres. What we need is that plus that equals 60. We want to know at what time these two together will have reached 60 kilometres. If you get that formula, it's party time. 30 lots of t plus 50 lots of t is 80. The opposite of multiplying by 80 is dividing by 80. So t is 60 over 80. If you simplify that or put it in your calculator, they'll tell you that's 3/4. Now remember, this was all in hours, so that's 3/4 of an hour. You also, because you're all brilliant out there, should tell me, how many minutes is 3/4 of an hour? 3/4 of an hour. 1/4 of an hour is 15 minutes. 3/4, you could also write it as 45 minutes. That is when they will cross each other. So they will pass at 3/4 of an hour or 45 minutes, depending on how you want to measure it. Now, the second part of the question, just quickly, says how far have they travelled? So part B, that was part A, yes, my bad. How far? Remember, we already defined A travels will have travelled at 30t. Essentially, it'd be 3/4 of 30. And you know, you could, oh, look, it's 22.5. A will have travelled 22.5 kilometres if you put that in your calculator. B is 50t, so that's 50 times the 3/4, which will give you 37.5 kilometres if you put that in your calculator. Now, most importantly, that question allows me to verify the answer. How? How far should both of them have travelled in total? 60 kilometres, right? Nice way of verifying your answer. That plus that will indeed give you 60 kilometres. It's a nice way of verifying your answer to this difficult problem. I actually did a quick run through of this question before I started, and that's how I verified I had the right answer. I used that logic. Anyway, that's a massive revision sheet, and this video goes for nearly an hour. Wow, it's huge. I hope you find it helpful. Have a great day, everyone. Signing off now. Bye.